Спасибо. So, can you hear me okay? Good. Hi, everybody. My name is Ilya, and I have two of my teammates with me here today from GTON Capital, Alex Telegan and Alex Pupashev. I'll probably be calling one of you Sasha and another one Alex, just to make it easier. So we're presenting to you again GTON Academy. It's a live stream series aimed at introducing and breaking down the basics of different DeFi concepts and protocols. We're hosting this live stream in partnership with Web3 London. And today is the second live stream that we dedicate fully to layer 2 solutions and rollups. So layer 2 blockchains, why do they matter? I'm pretty sure you all have heard the term optimism, Arbitrum, Metis. They claim to solve the scalability limitations of Ethereum while keeping the costs and the required trust level low. So what are they? How do they actually do it? What kind of features they have? And why scaling is so important in general for the Ethereum ecosystem? So some of those questions are going to be covered. Alex is going to start with a brief presentation, and then we're going to have a Q&A chat together between us three, just talking about the concept, why it is important for us as builders of our own layer 2 rollup, which is called GTON Network. So Alexei, you have the floor.
Hey guys, let me share the screen because we have some presentation. Host disabled participants. Guys, please let me share the screen. I cannot do it right now. Who is the host?
It's GTON Capital. So can you try again? Maybe they changed it already.
No, host disabled participant screen sharing. If anyone is able to share the presentation, please do. Or let me do it.
Sure, just a second.
Yeah, we're trying to reach the operator, so hopefully it's going to be fixed soon.
Yeah, please. So let's just Ilya, can you ask some questions from the community before we started?
Oh, sure. We can start with some basic questions, some sort of more philosophical questions first, before we because I also can't share it, unfortunately, so I have to fix it first. But in general, can you tell like about some of the biggest challenges in the Ethereum ecosystem and how are they being solved right now?
For the Ethereum right now, right?
Yeah.
So a lot of people are talking about the gas cost for Ethereum, and it's actually hard to use it right now because of gas cost. But surprisingly, layer 2s, they are not solving the issue of gas cost. Actually, they are solving issue of scalability. And today we will talk about scalability mostly and about different approaches how to solve it. So Ethereum has many different approaches to that and have it in previous, like probably you remember Plasma, you remember state channels, whatever. There were a lot of solutions, but right now we have only one popular solution, which is Ethereum. Those are rollups, and we have sidechains as well, and sidechains or alternative layer ones with the EVM, like Ethereum virtual machine. So sometimes it's all about marketing mostly. I mean, how you name it, because if you have absolutely separate chain with your own validators, but it's EVM. So what is Ethereum? Is Ethereum something about EVM, or it's about the main chain and everything connected to the main chain? So this is, of course, arguable questions, and we see that Ethereum is going to scale with its own architecture with sharding, right? So first of all, they have to finish the proof of stake, and then there will be sharding. But all the solutions we have right now, like sidechains, alternatives layer ones with the EVM, like rollups, they are all solving the same issue with the scalability of Ethereum, but not only scalability, but also on other approaches like gas cost or alternative gas currency for that. So I think that we will have multi-chain, multi-approach world with the Ethereum scaling. So guys, I have an ability to share the screen right now. Finally, thank you guys. Okay, let me open the presentation and share. Right, I have to do on the slideshow. So cool. You can see my my presentation here, and let's talk. I hope this will be it will not take a lot of time for us to look at the presentation, and we'll spend more time answering questions and discussing stuff, which is has sometimes much more sense. So in the previous blog of GTON Academy, we were talking about stablecoins, with algorithmic stablecoins, collateralized, crypto collateralized, etc. Those are disruptive innovations since several years, right? And the recent one we have right now is actually a rollup technology. And right now we see huge traction for rollups. Like really, one of the metrics of the traction is TVL, total value locked within the network, right? So this is basically the dollar amount of assets somehow used within the protocols on platforms. So, and right now you see the huge growth of the TVL for rollups, and the question is why it happened. Like why it happened, what's the reason for that, and now what's next? So the issue is actually the scalability. The scalability can be solved by many different actions. But what scalability means? Scalability means how many transactions per second can be executed, right? So this is like most important metrics here. And of course, it should be not so expensive. It should be as decentralized as possible, because we have alternative solutions. And this is something about scalability. And right now, Ethereum has some limits. It has some limits for the gas. So this is why the gas cost is going too much, then the network is congested, right? Because it has limits, how much gas can be spent within one block, but also the latency for transactions, right? For the blocks. And this is like around, right now it's more than 12 seconds, it's around 15 seconds, but it's, it depends from the network conditions. And most often, to scale the blockchain network, there are two approaches. First approach, pretty stupid. Like, let's use centralized intermediary to proceed transactions to operate with the users. Here we are actually facing the issue of centralization, because this intermediary basically the central authority for managing transactions, right? Speaking about centralized exchanges, we have solution here, because most of the centralized exchanges, they have centralized backend for processing transactions. Or we can make blocks bigger or more frequent or whatever, which requires more resources for the node validators, right? But the more resources you have for the node validators, the more centralization you have, because not everyone is able to afford to maintain those nodes. And here we have alternative solutions we will talk about. We have channels. We will not speak about channels anymore, because it's actually not a topic. I cannot say it's failed. For some application-specific purposes, it works pretty well. For example, loop ring, pretty okay. But we have to talk about rollups and sidechains and what's the difference between them. If you look at this, you will find that rollups and sidechains, they are all general purpose. What general purpose means? General purpose means that we have EVM, Ethereum virtual machine, and all the programs which potentially can be executed within the mainnet can be also executed on rollups or on sidechains, right? So this is like general purpose. And the programs, the smart contracts, the applications, they are able to communicate with each other. So this is how we have composability, right? And this is actually one of the most important slides from the presentation, because speaking about rollups and sidechains and layer ones, people are always misleading them both, and sometimes asking questions which has no place if you understand the difference. And we know the sidechains or alternative layer ones, right, which are using EVM, and we have rollups. So what's the difference? The difference here is that we have Ethereum mainnet, which has its own network of miners, right? And the miners, they are using the proof of work consensus algorithm for the block producing, right? And because it's incredibly expensive to do the 51% attack on Ethereum, just because it costs a lot in terms of electricity, in terms of complexity, this is why people trust to this network, right? To the main net of the Ethereum. And there are like thousands of validators who are doing the work with the proof of work. If we have sidechain basically means that we have another network with another consensus. And I know that right now Ethereum is using proof of work, so this is why we mentioned proof of work, but sometimes I hope next year it will be proof of stake. But most often, like 100% cases, it just doesn't make sense otherwise. Sidechains, they are using proof of stake concept, consensus model. So basically, they have their own network of validators, right? And this network of validators is proceeding transactions. So if people are using sidechains, they basically trust to the network of validators, not on the Ethereum chain, but on the sidechain, right? Same situation with alternative layer ones, sorry. So all of them, like Polygon, Binance Chain, Avalanche, whatever, they have different consensus, they have different, core, but because they're using EVM, they are absolutely alternative networks. Like they are separate networks. How Ethereum mainnet is able to communicate with the side chains? To communicate between both chains, which are absolutely separate. I mean, their security models and consensus are different, and network of validators are different. They are using bridges. Like somebody who is running the oracles nodes, because most of the bridges, they are relying on oracles, which are reading and writing information between different chains. They have their own network of nodes, which basically oracles or bridge validators, and they have their own consensus. So it's another network. So we see here that there is, like, if you have sidechain, it's not actually scaling Ethereum. It's basically something new, right? Something external. And it has its own ecosystem, its own network of validators, security model, and the risks. And speaking about the bridges, we have like a lot of bridges, and there are also risk of bridges, because sometimes they can be hacked. Validators for the bridges can be malicious, and this is all about risks. With rollups, we are not talking about another network anymore, because network basically means the network of validators, right? We are talking about something which is help us to keep all the data, all the information, and the security level on the mainnet of Ethereum, but at the same time let users to proceed much more transactions per second on another side. So basically, rollups you can see as off-chain aggregation of transactions, and storing them into the Ethereum mainnet. So basically, rollups are rolling up the transactions which are outside, and then they are pushing the results of the transactions into the Ethereum mainnet. And since they are using Merkle roots, which is basically the hashes from the transactions, right? It's possible for anyone to verify that the sequence of transactions are valid or not. So this is why we have only one player here. And the name for the player here is sequencer. So rollup is kind of off-chain of Ethereum thing, right? It's another layer, and it's collecting transactions for the users with their signatures, and all the executions, and then sequencer is pushing the data in the form of Merkle roots into the Ethereum mainnet. So this is why it's actually part of mainnet. It's not a separate chain. It's not a separate network. It's part of mainnet. And moreover, the whole history of the rollup is storing into the mainnet. So there is no way that the data will be lost or changed somehow. Everything which is going on the rollups is basically storing and is a part of Ethereum mainnet. So this is most important thing for today, and then we'll just look at the details, how it can be executed, etc. But the side chains and alternative layer ones with Ethereum virtual machine, those are completely separate networks, right? So this is most important thing here. And guys, if you have any questions here, just ask. We'll go later into details.
Yeah, maybe I'd like to ask a little bit about the sequencer itself. So it seems to me that in order to keep the network decentralized, you will have to maintain both low cost and also a low trust level required for the network. So how can we make sure that people actually trust what the sequencer does off chain, and what's the required trust level here?
It's a good question. It's actually called fraud tolerance here, and it's implemented as a dispute resolution. So we'll look at this, how it works. But before we'll start, we also have to look at what kind of rollups we have, because we have two different types of rollups, optimistic and ZK, right? So rollups, basically off-chain transactions collecting, and sequencer is pushing them into the mainnet. And it's solving scalability issue, right? Because we have in Ethereum, we have 15 TPS transactions per second or up to 50. And then rollups are scaling that to the thousands transactions per second. And then the Ethereum 2.0 will be, live. We'll have shards, and each shards can be connected with the different rollups. So the scalability will be, I cannot say infinite, but exponential scalability here.
I also wanted to add here that when the sharding is live, we can actually store more data on the Ethereum blockchain, because right now there is also a data limit on how much information, etc. you can host. And with the shards, this limit increases.
Exactly. So let's go. How rollups works. As far as I already explained, rollups are basically aggregating data outside of Ethereum and in secure way in the form of Merkle roots, storing them into the Ethereum mainnet. And I hope you understand how Merkle roots works, but let's look at this a bit more carefully. We have different balances on different wallets, right? And this is actually the state, right? So this state can be recorded as hash of different balances or transactions. So hash is actually much easier to store. And then you have hash. You can prove that the information which is which we're using for creating this hash is valid, because it's single one side cryptography here. And keeping the Merkle root, you can always say, is it true or not about any states which were as a source for these Merkle roots, for those hashes, right? So using that, you can always keep the information and then have an ability to verify. So how it works, basically, there are two different approaches for that. One is zero knowledge. Zero knowledge, I have one joke. Everyone has zero knowledge how zero knowledge works. It's like, it's absolutely difficult, to be honest, because most often it has its own cryptography and specific for different types of transactions, different types of applications. So right now we still have almost zero adoption for the zero knowledge rollups, but anyone agreed that it's a future. But it seems like it's a future, then it will be more advanced in math, because right now we have some issues. And what is actually working right now on the production and has TVL and has some traction from the users, those are optimistic rollups. And there are two different types of optimistic rollups, not because of different algorithm or something, but because of some rollups, they are choosing to use the Ethereum as a gas token. So basically, you are locking Ethereum on the bridge, right? Moving Ethereum into the rollup and using it as a gas currency for the rollup itself. So in terms of user experience, there is not so much difference between using Ethereum and using rollups, which are using Ethereum as a gas token, because basically you are using one currency. So those are most popular at the moment. Most popular rollups: Arbitrum, Optimism, and Boba. Surprisingly, but Optimism and Boba, they have their own tokens, like governance tokens or retroactive airdrop tokens, whatever. They have a lot of R&D around how to optimize the how sequencer works, the way how sequencer works, like create multi-sequencer approach or whatever. They have some differences, but to be honest, it's almost the same in terms of design. So the Arbitrum, Optimism, and Boba, they are using Ethereum as a gas token. But there are also another layers too, which are not using Ethereum as a gas token, which have their own assets as a gas token. And here we have Metis, which is using its own coin, and the GTON network, which is using stablecoin, collateralized stablecoin as a gas currency. So going back to the optimistic rollups, Ilya asked important questions about how it basically works. About ZK, I cannot say, because no one can say. It's, even if somebody will say, nobody understands. It's a math. It's also about the compression of transactions and storing them securely within the chain. It somehow helped to do it more faster, more optimal. But on the practice, we have optimistic rollups which are working right now.
But if you want to, I'm sorry for interrupting, but if you want to look up how actually the ZK math works, you can look up the ZK SNARK cryptographic proof, something to be pondered on the weekend, I think.
Yeah, but it's anyway, it's impossible. I mean, like right now we are focusing on the people who are not, who has no cryptographic math actually background, right? But even if you have math background, but not like so deep cryptographic, you don't understand, because basically it's like it's a math. It's like how you are playing with the different functions and how they are connected to each other, and it's basically is. But the thing is, it's not working on production as we are expecting. Actually, not yet. I hope it will works in a couple of years, but not now. So the whole focus of the presentation right now will be around optimistic rollups. And the question Ilya asked, it's most popular question actually. Like, since you don't have the network of validators and you have no consensus at all, how you will be sure that sequencer is not cheating with the transactions, right? There are many types of how sequencer is able to cheat. Sequencer is basically the account or the machine, the processor who is collecting the user data, signed transactions data, and then put it into the mainnet, connecting with the smart contract on the mainnet. So the question here is the dispute resolution. As you can see, there are two different things. First, if no one created challenge, right? I mean, if there is like absolute certainty that the sequence of transactions from the rollup is stored correctly within the mainnet, no dispute, it's just, everything is okay. If there will be some kind of doubts about what's happening, there will be a challenge, and the challenge will works as the dispute resolution between both. And the verification is actually pretty easier, because all the Merkle roots are already, if you have Merkle roots, you can easily prove is it true or not, like is it correct sequence of transactions or not. So you can easily verify them. And how it works, you can see that we have we have different blocks on Ethereum, we have different blocks on rollup, we have different transactions, and most of them are okay, but one is not. So we are facing the operation which called fraud proof, right? And because we have all the story, all the transactions, and we have Merkle roots, we are able to verify. So it works as a challenge between sequencer and the challenger. So the challenger has its own assets to challenge the dispute, and then we have Alice. In our case, we have Alice as as a sequencer. So to proceed the transactions, Alice is using bond. Bond basically it's like it's like amount of money. In our case, Ethereum, you are using to potentially play in this game, into the dispute game. So Alice has one Ethereum, and she is a sequencer of the system. Imagine Alice publishing the fraudulent state, right? Bob, who is a challenger, he noticed that something is wrong, but in order to challenge Alice, in order to challenge the sequencer, he's using his own Ethereum, and they are starting the game. So if Alice is not true, if Alice did the mistake with the transactions, whatever reasons, it can be malicious or not, whatever. So the Bob is winning the challenge money from Alice, right? So we have penalty here. If not, we have everything is okay. Like Alice is taking money from the Bob because Bob is challenger here. So but there are some cheating approaches here, and right now in practice, both participants are taxating to burn some transactions just to prevent any kind of game around that, right? So this is how actually dispute resolution works. Like anyone is risking their funds for each confirmation here. And the thing is, everything which is already stored into the Ethereum chain and already verified, we can call it rolled up, it is here, it is on Ethereum. So even if we are changing the sequencer, there's all information is stored into the Ethereum mainnet. So all the states can be actually reconstructed from the Ethereum mainnet, and the network will continue to work. I know it's difficult to understand because those are different small pieces, but this is like idea, right? We have challenge, we have some ability to prove who is right, who is not. But the thing is, probably we can see it later. The thing is, it takes some time. The challenge takes some time, and this is why the most common critique around the optimistic rollups, those are around the time for money withdrawal into the mainnet, because we need some time for the challenge, right? And it used to take up to 1 week. How it's actually then you can challenge that. So this is why this is the most popular critiques around the optimistic rollups. And coming back into the ZK rollups, we can see that ZK rollups already in production. We have some projects, but most of them are project specific, like application specific. Most of them are exchanges, and they are not working with the EVMs. Only ZK Sync is trying to build the EVM for ZK rollup, but it's also limited. I mean, there is no general purpose ZK rollups. And going back to the pros and cons of both, right? Optimistic rollups and the ZK rollups, we can see that the only issue right now for the optimistic rollups is withdrawal time. So yeah, this is exactly what you asked, right? About how to be sure that there is no vulnerability within the sequencer, within all the stuff. So this is actually the weakest point of optimistic rollups. But there are many solutions, to be honest, because everything can be verified. So the market makers, those who are providing liquidity on both sides, they can actually cover this issue. Of course, they are actioning like an insurance company here, but since they have enough equipment to verify everything what's going on with the transactions, they can allow people to do transactions faster, basically by taking risk, right? But this risk is easy to compute. And this is why if you try it Optimism, for example, you will find they have two different options, like, you know, the real bridge and the fast bridge. I forgot the name of the fast bridge, but, you know, they have different options. With the optimistic rollups, we have another issue. Withdrawal time is pretty fast because, you know, there is no time for the challenge because it's a different approach. But the issue is because of ZK is incredibly hard in terms for the execution, and there is no EVM compatibility yet. So this is why most of the applications or ZK rollups, those are application specific, because it's easy to create the ZK proofs and ZK architecture for something you know how it works, like, you know, the limits of, you know, methods or API, but it is incredibly hard to build it for general purpose EVM. So yeah, this is a classification of rollups. I hope it is helpful, because sometimes it's difficult to understand how they are classifying. And right now we can see that on the market, we have 4 most popular rollups, and Arbitrum is dominating here. Optimism is going next. But I think the future is here for that, because, you know, there are so much benefits. In terms of GTON chain, we are building our own rollup solution. We are using and utilizing the technology of optimistic rollups from the Optimism. But the difference is that as a gas currency, we are not using Ethereum. We are using GTON dollar, which is collateralized stablecoin. And we think that this approach has a lot of benefits. First of all, for users, stablecoins are absolutely obvious, right? They are paying, you can fix it on some level. So, and they have money on your chain to use it. They have no volatility risk, right? I mean, they just keep money on the wallet. They can do transactions, and there's no volatility risk for their native currency, because most often on different chains, you have this issue, right? Of course, you can minimize it, but it's just use case. Another approach is that having a lot of applications on your chain, most of the trading volumes and liquidity and use cases, those are around the stable coins, right? So this is why we decided to create the scaling solution for Ethereum, but it's with with the stable coin as a core, as a currency there. And there are many options how to monetize it. I told before that different rollups, they have different approaches how to accrue the fees from the system, how to capture the value from the usage of rollups. We have pretty simple approach. We have our own coin, which is GTON, the governance token, and you can stake it. You can stake GTON on Ethereum, or you have algorithmic collateralized stablecoin, which is GTON dollar, and it is actually native currency for a rollup, and you can stake it on rollup. And because we have activity on rollup, we are generating fees from all the protocols, all the users on the rollup. We are distributing both. So people, they have an ability to choose their risk profit profile by balancing how much GTON they are staking or GTON dollar they are staking. So this is an approach. And we are all side chains and the rollups and the Ethereum core protocols developers, they are working for the same thing. They are helping to scale Ethereum and actually bringing even more value into that and into the DeFi itself. So I think it's all from my side, guys. Let's go to the question and to the interesting part.
Yeah, sure. I do have a couple of questions here, but first, maybe I want to ask Alex Tillagin whether he has anything to add to other Alex's presentation. Maybe some observations or details, anything that you noticed.
And I wouldn't say that there's anything in particular. Probably we can cover this stuff during the Q&A session, and yeah, sure. I'll see what I can add there.
Okay, sure. So my first question then would be, could you describe the user journey with an L2. So if I want to enter the L2 system, I want to deposit, what should I do? How do I actually do it?
It's a good question. Let me find, do I have some slides for that, because I cannot see it. It's a good question. So how it works? Basically, if you want to work with a rollup, you have to be on Ethereum, because you are not on rollup yet, right? So you have Ethereum. First of all, you have to bridge your Ethereum into rollup. So as a user journey, you're always starting from the bridge. And most often bridge is asking you to add the network into the MetaMask if you're using MetaMask. So you are, adding the rollup as a network into the MetaMask. And then the bridge is asking you to deposit assets into rollup, because you have to use some assets to send transactions to operate with the dApps. So first of all, you're starting from the bridge, then you bridged assets. You can bridge Ethereum. And if Ethereum is a gas currency on rollup, it's actually enough, you can continue. If not, the bridge is asking you to deposit another currency. In our case is GTON dollar stablecoin. In case of Metis, it's a Metis. So you can bridge those assets on your wallet on rollup, and then it's done. You can continue to work. This is actually pretty fast, because only withdrawal takes some time. Bridging into one side is actually faster. So you can operate on rollup and do transactions there.
All right. Yeah. So okay. So one of the other questions that I wanted to ask before, when you were talking about verifiers, there seems to be a couple of different issues that may arise with a system that has a separate entity for like a verifier. And so if I want to like participate in a rollup as a verifier, what should I do? Is there some kind of like a node that it should run, or something like that?
So anyone is able to be a verifier. The only thing is you have to have enough computational power to verify the states and the numerical roots. If you have enough computational power for that, and you absolutely sure that your computation setup is actually able to verify where is a fraudulent state update and there is not, you can challenge. Then you notice that, so everything you need is actually enough power, computational power, and the setup for reading transactions and verifying them in terms of Merkle roots. And also you have to have enough Ethereum to be a challenger, because you have a chance to lose it. It's not always profitable. If you have some issues with your node, you can actually lose money. So this is it's kind of game. But if you are right and the sequencer is not working well, you can earn some money as a verifier. So I can say that it's more about professional players there. It's not like staking. It's not like mining, because there is no guarantee that you will always get rewards from that activity. Yeah.
So it's essentially like an adversarial situation where two different entities, they are sort of in the opposite positions, and one tries to commit fraud, another one tries to actually detect that, and that's the incentive structure that the rollup has, right?
Yeah. The thing is, anyone can be this entity. I mean, anyone can be a Bob. So this is, it's like it's open, right? You cannot hide somebody. If the network is open, everything is open. So there is no way to change yourself for that.
Yeah, sure. So Alex Ligon wanted to add something. Go ahead.
Yeah. So amongst other requirements, so actually, like if you want to submit fraud proofs, you actually need to be running two nodes, like both a full Ethereum node as well as the full L2 node, because you need all of that information to actually keep track of the state of both blockchains and verify data this way. Also, like there were some discussions about like whether or not these incentives program in general works, because like for example, the more validators we've got, like the better like the system in general becomes like at not actually generating any potentially fraudulent activities. Then if something like this happens, running a fraud detection node is basically not profitable, because you just have to maintain two full nodes of two different blockchains, and at the same time nothing ever happens. So you don't get the actual reward in ETH, in locked ETH for submitting the fraud proofs. But like in general, we have to consider the fact that if you are user of L2, and especially like if you've got some of the dApps deployed on that blockchain, it is in your best interest to actually be verifying that everything that happens on chain is not a fraud. So that's why there are many cases like players like Uniswap, for example, who've got like billions of TVL on different L2 rollups. They might be running those nodes as well. And also, as we've been talking about, those instant cross-chain swaps that are not going through the 1 week bridge, but allow you almost simultaneously transferring the assets between accounts. This actually happens because, first of all, some players have assets on both chains, and at the same time, they are able to verify to a certain degree of certainty that the current state of the blockchain, of the proofs that we've got on Ethereum is representative of what's happening on L2. So basically, to do that, they have to be constantly on the search for any type of fraud, and that's why those players who are running these fraud detection nodes, they might actually be running bridges that allow them to earn money out of having this knowledge at their hands.
Yeah, absolutely agree with Alex. I mean, it's actually a good point. There is no direct monetization from the design, from the algorithm design, but in terms of economical design, it works, because if you have a business on the rollup, you are generating fees from whatever activity, right? Trading, lending, borrowing, NFTs, whatever. So it's up to your interest to not be hacked, right? So this is like the cost you have, but rewards is in different approach. You are basically running something on this network. And for the bridges, it's also true. I mean, like if you are doing bridge, you can actually tax all the transactions. So if people are moving funds in both directions, you can tax these transactions, and you can make money from that as well, on different reasons like arbitrage, or people just withdrawing funds. You can easily monetize it. And again, to let the business work, you can verify and challenge the sequencer. So this is how the design here is economical ones, not the technical ones. Good point, Alexander. Thank you.
Yeah. So another question that I see, and by the way, thanks a lot for the remark. A lot of people are asking this question: how does the merge of Ethereum how will the merge of Ethereum influence different rollup solutions that exist currently on the market?
Alexander, you know the answer?
The general consensus is actually that it's not going to affect the rollups, and probably it's going to even increase the general usage of L2s, because this allows for even more scalability of the blockchain application. So in general, it's not direct competition to the variety of rollups that we have right now, because anyway, the transaction throughput of one chain is going to be limited, even with shards, etc. So most likely Ethereum is going to continue to be like the root of all the L2s that people rely upon for the verification, etc. But it's like there is too much demand for fast transactions, and that's why rollups are still going to be in place after that.
Yeah, the question is pretty easy. The main network will not go anywhere. I mean, there will be shards, there will be some kind of solutions on top, but the mainnet is not going anywhere. And the consensus actually doesn't matter for rollups, because the consensus has nothing to do with the cryptography. I mean, the cryptography for the transactions verification, right? So this is why after the Ropsten, right, merge, nothing changed actually. In our case, nothing changed, and most of the rollups, they have no difference, because the consensus is about the network security. It's not about cryptography for the transactions and and the hashes. Cryptography didn't change and will not be changed. So this is why it will not have influence on that. And moreover, if you look at this slide, you will find that rollups, they have interesting approach. Rollups can be rollups for rollups. It's like fractal approach, like it's actually creating the the infinite scalability here. And with Ethereum 2.0, there will be the same. I mean, you can do rollups on rollups, you can do rollup on Bacon chain, you can do rollup on shards. Like there will be a lot of combinations. Depends on your needs. For some applications, it's better to have rollup on top of rollup, because you can, you can do transactions even faster. For example, for the games or exchanges, whatever. But yeah, there will be only positive effects on that.
All right. So actually, I've almost exhausted the list of questions. So maybe I'll just try to get some off the top of my head. Could you maybe describe the difference between the three optimistic rollup solutions that you mentioned, which is Arbitrum, Optimism, and Baba, if I'm not mistaken? Was that the third one?
Yeah, let's go. Let's look at them first of all. Okay, here. So those three are using the same approach. The only differences there is about their research around how to optimize the sequencer. For example, Arbitrum is trying to push a more decentralized sequencer. Optimism is trying to use the null approach with the op token, but to be honest, almost the same. I mean, really, if you look at the documentation carefully, the changes are like, for example, Bobo is saying that we are DAO. Like, really, like difference is there's a bunch of criteria. And for example, Bobo from the Optimism, they have differences in terms of details of implementation. Like Optimism works with the wrapped Ethereum, which is ERC20, but Bobo is trying to work directly with ETH, which is not ERC20, which has different. But to be honest, no difference. I can say almost no difference. Just question of marketing, question of how R&D is going. I mean, how they are trying to incentivize people to actually to build something on top, right? For example, between Arbitrum and Optimism, we have at least one difference. Optimism has token, and they have the plans for the block space, which will be work as a competition between different sequencers. So those will use the op token for that, but it's not working yet. It's in the plans, and how it will be executed, nobody knows, right? So we cannot say with a 100% confidence that there will be something or not. About Bobo, they are saying that the Bobo is a token which is using for fees distribution from the sequencer. So here is, it's also different, but again, it's not different within the design. The difference in terms of incentivization, in terms of token models, and Arbitrum has no token yet, but there are a lot of gossip that it will be.
Sorry.
So
yeah, sure.
The question, then it will be a token. There will be even more difference, but in the end, they are using the same approach. Like basically the transactions are rolling up by sequencer into the main net of Ethereum. But incentives, fees distributions, whatever the approach to decentralized sequencer, they are different. They have some difference.
There's one major difference though. and it comes from the user experience, basically. I think the Boba network actually, they claim that they decreased the dispute period, where you need to still keep your locked funds on the rollup from 7 days to, I think, a few minutes. So it's an interesting innovation.
But you know, it's also arguable. If you try optimism, I told you they have their own approach to speed up it. It's not speeding up by design of algorithm. It's speeding up by some alternative protocols on top. So if you try optimism, you can do both transactions on both sides for like seconds, right? Not seconds, probably minutes, but it's really fast. Why? Because they have liquidity on both sides, and for some amounts you can actually choose. It's called, guys, do you remember how this Zap works? Not a Zap. It's like a Greek god name, like fast bridge for optimism. Let's try to see. I hope
it's Hop Bridge.
No. It's absolutely different thing. No, it's absolutely different thing. Hop Bridge, it's a third party. It's third party. It's not connected anyhow. But Optimism, they have their own. So there is actually not so much difference between both. Speaking about Boba, let's do the experiment and open the Boba. 1 second. Somehow I cannot open the browser.
Just press escape.
Okay, I see. So here we can find it's actually pretty interesting. We can find the GitHub of the Boba. 1 sec. And in the GitHub, they have an explanation, like what exactly they have in difference. Not here, somewhere.
I think it was at the very top.
It's here. So you see, Boba has difference from the optimism, right? But basically, it's based on optimism. Like if you're running their own rollup, try to fork optimism, do some optimization here because it's a public good. But keep open source. So providing additional cross-chain messaging, it's actually nothing. It's just optimization for something. It's not design difference. Using different gas pricing logic. Come on. Sorry, I'm not trying to say something. I'm just trying to show that the difference are not about changing the protocols or something. It's optimization. It's good because even optimism can reuse it later. But it's not dramatical changes between both. And we have to be fair with that. We have to speak in the truth about what is there a difference or not. Providing swap-based system for rapid swaps without 7-day delay. How it's solved, I have no idea because they are using the same approach. Community fraud detector. How? It's already there. It's like it's they're naming something, but there is no way how it's different. Interacting with the L2. This is okay. This is important. I mean, it's really optimizing the gas. Then you are communicating with the wrapped Ethereum, which is ERC20, or then you're working with the native Ethereum. It is a good thing. But again, it's not enough for differentiate them. Like optimism can adapt this easily. This is, we know how it works. Being organized as a DAO, there is no criteria as what is DAO, what is not, because you can be a hybrid system. You can have foundation, you can have holders, you can have on-chain governance, off-chain governance. It's just like marketing thing. So the being organized as a DAO, we cannot count as well. We can say that we are also organized as a DAO, right? And it's actually the truth. We have proposals, we have votings, but it's not about protocol design. It's something else. It's about how project is going, right? Native NFT bridging. Come on. Automatically relying classical 7 days exit, blah, blah, blah. So you can see that there is no difference. Then we are talking about one rollup, optimistic rollup, another optimistic rollups. The real changes are not connected to the design at all. And even if some protocols, they are using more optimized solution for something, another rollups protocols can easily reuse it, and it's actually good because they are doing, all of them are doing good job for the speed. Yeah, Alexander.
Yeah, I just want to say that basically, like half of this functionality is on the side of bridge contracts on Ethereum. So basically, you can do an easy redeploy of the contract or update it through the proxy, and basically that's it. So you don't even need to update the L2 chain itself. It's just several contracts on Ethereum, and that's it.
Yeah, of course. If you look at the classification, there are a lot of changes you can add on both sides actually, because if you have optimistic rollup like fork optimism, but you are trying to use your own chain, you have to breach, you have to breach the address and the data of one coin which is already exists, like for example ERC20 coin on Ethereum, into the native currency on rollup. So it's happening within the genesis, right? But again, like in terms of design, Metis has almost no difference from the GCNet, and at the same time, Metis has no difference from the optimism, except the fact that Metis is using ERC20 token as a currency. And between Bobo optimism, we saw it's not many difference. For Arbitrum, it's a bit hard to say, to be honest. I have no deep experience in Arbitrum because we are focusing on optimism and its customization for our own needs, mostly focusing on customer apps. But somehow Arbitrum is winning. But I'm not sure it's a question of design. I think it's a question of supporters. Like they are all supported by different VCs. Those VCs are different, means that different protocols communicating with the different rollups, and this is influencing the TVL and popularity. Yes, Alexander.
Yeah, I also wanted to say about like the way that Arbitrum launched, because Optimism initially open to like very small set of protocols like Uniswap, etc. While Arbitrum allowed a window for any projects to launch, and that can probably affect like the number of protocols that are on chain. And then eventually, like if so many people are already using it, then it makes sense that there is a network effect and other people come here. But again, like this is all purely like marketing and like the correct launch procedure.
Yeah, absolutely agree. Eliab, do you have any other questions? Like really, like what do you think about rollups?
Yeah, I'm thinking that maybe there's another question buried somewhere in here, which is, but it's it's pretty easy to answer. But I think we actually need to wrap up soon, so maybe that's going to be the final question for today. And that question would be, why actually build a layer 2 solution instead of a layer 1 blockchain?
The answer is pretty easy. You are not building your own network of validator and all the costs you have after that, right? So let me show this slide because it's important, one of the most important here. Then you are building the rollup, you are on ETH, and all the funnels, the onboarding, the security is on ETH, and you are basically scaling ETH in that situation, right? Then you are working with the sidechain. You have to be sure that the network of validators is actually trustful, because especially with the proof of stake, most often, if you look at the validators, there is no decentralization anymore, because like if the team launched the coin with the VC support and they have majority of the coins, of course they are actually maintaining the node. Like I cannot say anything bad about, for example, Binance chain, Binance Smart Chain or BNB, but we all know that we cannot say it's like independent network validators, right? It's basically the companies which somehow affiliated with the Binance, but it's okay. I mean, if people trust this, it's okay. It's trusted system. Yes, it's somehow distributed. The network distributed. It means that the reliability of the network is still high. If the validator is not working anymore, it can be easily replicated by another one, and everything is okay. the information stored on different machines. It's like, but we cannot say it's decentralized in terms of politic, right? In case of proof of stake, small chains, like, then you are launching your own chain. There are a lot of questions how you will bootstrap the network of validators and how you will convince users that it's not your 10 or 11 nodes you are running on your machine, this is issues. And this is only one issue, actually. The second issue is breach, because in the case of rollup, you have, of course, weekly breach, which is long time, but you have it. You have the chance to breach all the assets on both directions, right? Because they are using the same state, the execution state. But so with the sidechains, you have not only the network of validators for the consensus, you also have the network of oracles you have to trust. So it's like double, the level of risk is much bigger. At the same time, there are many benefits from that. If you're absolutely confident that your network is much better and you are growing fast and you can do whatever you want with that, you can grow fast and it's okay. But you are not connected to the Ethereum, except the fact that you are using EVM as an execution. And people who are forking the dApps on Ethereum, they can easily fork it on your sidechain or on your layer one. So after that, it's not part of the Ethereum anymore. So yeah, this is most important answer here. And guys, you have any more questions, or I can do some kind of recommendation?
Well, I think it's unfortunately time to call it a day and wrap up the event, but you can do your final word and then I'll say something else.
Yeah, so guys, you probably noticed that there are some nice visualizations here. Those visualizations really help to understand difficult stuff like rollups. So I used some of them I did myself like this. This is pretty easy, but those type of graphics and simple explanations you can find on Finematics videos on YouTube. So for example, this explanation, all those things are open and you can find on Finematics. Also, Finematics has a lot of different explanations for DeFi, for rollups, for scaling, for NFTs, whatever you're gonna see. And another recommendations are the official articles on Ethereum Foundation. You'll find the optimistic rollups on Paradigm Research. They have good articles, like everything you have to know about rollups, most of materials from there. And the last one, probably, guys, you remember the last one? What it was? Of course, documentation of optimism and Arbitrum, etc. In my experience, we found that documentation of optimism and basically the old stuff around the open source is much easier than the Arbitrum. But I hope Arbitrum will do things better in terms of documentation. And yeah, we'll see more and more solutions. So I want to say
another one is Vitalik Buterin also sometimes blogs about different rollups.
Yes, exactly. Vitalik Buterin.
Point of view.
But his explanation is very hard to understand, really. Really. He has math experience, we know it, but at the same time, the level of explanation is not for every Joe to go in and got something. But for devs who are doing research in that field, it's highly recommended. Yes, it's true.
So yeah, just want to do a quick final remark. I want to say that our thanks goes to Web3 London for organizing this live stream with us, and for the audience that joined us today. So we're going to see you in a while, hopefully next week, with some new educational content. And don't forget to subscribe both to Web3 London and GTON Capital for the new releases of GTON Academy. So it has been a pleasure. Bye, everybody. Thank you.
1 second, please. There are people who are watching the stream right now, and they are saying that we have a lot of friends, especially from the MOBA. So everything we explained, it's not about good things or bad things around things. It's just about the reality. And there are no offenses to anyone. I mean, Metis, Bobo, Optimism, Arbitrum. We just try to be like, focusing on what exactly going on. So I absolutely sure that Bobo will be successful, Metis will be successful, GTON network will be successful, and all of the rollups will be successful. Why? Just because they have different approaches for the community building, for the project attraction, incentivization, and the thing is, the more rollups we'll have right now, who are actively attracting users, the more chance for the success we will have, because there is no such thing as competition between rollups. Of course, sometimes person like DeFi user will do some, some options like which network to use. But in the end, it's all about the dApps on the network. It's not about the network itself. And the dApps can be built multi-chain. I mean, the dApps can be built on top of all the optimistic rollups. And because those have different offers for the users, the users win, right? So, and because of users win, we are all winning. So yeah, no offenses to any solution. And let's disrupt the market.
Yeah, sure. Thanks for adding that.
Okay, so and that's it.
That's it. Thanks, everybody.
Thank you.
Thank you, guys. Bye-bye. We need some sign, then it stopped. Somebody say something.
I'm checking it right now. Give me a second.